Hey, everybody, people are welcome. People are just piling in right now, so we're gonna wait a minute or two till the rate of joining slows down a little bit. So sit tight and we'll be with you. Christy, what do you think? Do we want to? Should we get started or give it one more minute?
I was going to give it another minute, but we can start. We're at 36, and we're really excited because apparently we have 86 registered. So I can kind of just give the overview if we want, and hopefully the rest of them will come in. So just to get us started, my name is Christy Erickson, and I'm the facilitator today. We wanted to thank you all for joining us for the FCMaP Mid-Year Forum. I know that everybody is really busy, so we really appreciate you taking the time to actually be here with us. We're really excited about the results that we have to give you today. So I'll just quick touch on, let's see here, a couple of the teams, just some webinar logistics. Again, we really encourage you to engage with the fellow attendees and speakers, the organizers, but we're hoping to take questions after the presentations. So if you do have a question, please announce yourself prior to your question. This event is being recorded. Just wanted to make sure everyone's aware of that. And it will be available on the FCMaP Hub. I just put the agenda in the chat box a few minutes ago, so you should be able to find that there. If anybody has any comments during the presentation, but they don't want to voice them, or if there's comments for follow-up, we'd love to hear from you. So please feel free to email me, the email address there. And then I'll just touch on some housekeeping. I'm sure you've all realized you do have the ability to mute and unmute yourselves, but we're hoping that you'll utilize the chat until we have this specific time for questions. I will provide the opportunity for people to ask questions once you raise your hand. But if you prefer, please utilize the chat box. I'll be monitoring that as well. After the presentation, if you raise your hand, I will prompt you to go ahead and ask your questions so we're not talking over each other. And I'll just take you through our agenda quickly here. Currently, we're in the middle of the welcome and agenda overview. We have, as I said, quite a lot of new and exciting information coming your way. So I'll really try to keep this on schedule, but we still want to make sure that we have a good discussion and that we hear from everyone. And so first up, we will have a brief FCMaP overview from Cheryl, and then she will give you some of the initial results from the deep water prioritization. And I just wanted to point out that the initial call for organizational point of contacts for the prioritization went out in our FCMaP April newsletter with an official solicitation for representative stakeholder organizational point of contacts going out in an email campaign on June 2nd. There were multiple follow-ups to that. So that's how we recruited the organization point of contacts that participated in this prioritization. And then we will move on to a little overview of the FSMI project. Unfortunately, no one from DEP was available to be here for this, so I will do a quick overview and just I've got a couple of screenshots of the hub site, just to kind of help you get through there if anybody wants to see updates. And then we'll hear from 2 of the 3 FSMI contractors for updates. So I think at this point, unless someone has questions, at this point, I'll turn it over to Cheryl for her presentation.
Cool. Thank you very much, Christy. I'm going to go ahead and share my screen. Share this one. Whoops. Slide. There we go. Hang on one sec. Let me make this full slideshow mode. There we go. Okay, well, whoops, sorry. Welcome everybody, and I think everybody probably knows me by now, but I'll introduce myself. I'm Cheryl Hapke. I'm the chair of the FCMaP Science and Technical Advisory Council. And my co-chairs on that council are Ashley Chapel is the federal, Noah is the federal co-chair, and Renee Baumstark is with FWRI. FWC is the state co-chair. And then we have all the usual players, mismatch of different state and federal agencies that continue to participate in and support FCMaP. I am also just want to point out that I am a PI on the with the Center for Ocean Mapping and Innovative Technologies, and so kind of being the liaison between COMET and mapping activities in general in the state of Florida. Let's see. So I think everybody knows we have one of the coolest logos out there, the Florida Coastal Mapping Program. We do need to make stickers at some point. Would be really cool. Anyway, what is FCMaP? Really, all we're trying to do is coordinate. We do not want to map. We don't want money for mapping. We don't want to be a clearinghouse for data. We don't want to QA/QC data. We don't want to do any of that technical work. We're more of a high-level coordinating body. So we make sure that everybody who's doing any kind of mapping anywhere in the state of Florida, which does have the largest coastline in the lower 48, that people know what everybody's doing and can hopefully help facilitate collaborations and dissemination of information. So really our biggest 2 charges, I believe, are coordination and then communication amongst ourselves, but also with you, our stakeholders. So thanks again for being here today. I'm not going to go through this in detail. If you want to see this, the link is at the bottom of this slide. This is our FCMaP accomplishment timeline. You can see we've been pretty busy. I mean, we really have had some successes for a group of dedicated agency representatives who have stuck with this program over the years and really taken us, through a lot of successes. So we're quite proud of that. And again, I just want to focus in on 2023. In 2022, we developed a strategic plan. Again, if you'd like to see the strategic plan and look at it, you can always go to this website. And then we decided this year that it was worthwhile to undertake a second prioritization that focused on the 20 to 200 meter water depth. And I'll get to why we made that decision in a moment. As I mentioned in my opening, we really want to coordinate and communicate not just FSMI activities, but all mapping activities that are happening in the state. Continue to do that. I'm going through these really quick. So everybody's seen this before. This is not the new stuff. This is the original prioritization. If you remember, in 2019, I believe, it was before COVID, 2019, a group of us toured to 5 different places all over the state of Florida, held workshops, and what we had the point of contact representatives from the different agencies and entities. We used a coin method. And so we gave everybody, we divided the state into 6 regions, and we divided the regions into 10 by 10 kilometer grid cells. And we gave everybody a certain amount of coins for each area and asked them to populate the grid with, a certain number of, coins, the highest number is going into their areas of highest priority. And then we turned that into an index because the number of grid cells in each area, each region, as you can see on the right-hand slide and the left-hand slide, vary. We normalize the data by dividing the number of coins by the number of grid cells. So we have this index, and you can see that what the results showed is the reds and deep oranges are being the highest, and even just any orange being the higher priorities, really hug the coastline. So it was all in the, not all, excuse me, I misspoke. It was largely focused in the 0 to 20 meter depth zones rather than deeper water, although there's quite a bit, especially on the shelf down near the Keys and up near Jackson, off of Jacksonville and the Northeast coast. So this is what we would. Then this is. This led to the FSMI program, the Florida Seafloor Mapping Initiative, that's being run by DEP. This helped them to determine that they were going to focus the initial mapping with that program in these shallower areas, and that's happening now. We'll hear about that later today from Christy, and we can talk about it. But the reason we decided to undertake the deeper water prioritization really was because we thought, now that these results are, the initial results are in, it would be nice to see where people still have high priorities in those deeper water zones. And so that's why we decided this year to undertake that. We did it a little bit more simply, as you'll see. Just want to wrap up on FCMaP. I think that we come at this from, each person has their own reason for wanting, seafloor mapping data, but almost every one of these activities in some way, shape, or form, the bathymetry is the foundational data that are needed to really accomplish any of the things on our wheel of benefits, if you will. And it certainly isn't exhausted by those that are listed here. And we, of course, adopted NOAA's map once, used many times. We consider our mapping program to be one of NOMEC's state mapping campaigns, and we want to coordinate with their efforts. We want to support FSMI however we can, however they want us to, and any other mapping efforts for that matter. And just wanted to note that Florida stakeholder prioritizations and updated inventories are something that we're going to continue to do. That was all I had on my introduction. Hey, the website link there is, again, my email if for whatever reason you want to contact me. And I'll just really quickly, I doubt anyone will have any questions, but if anyone out there, I'll pause for 1 second in case somebody has a question or a comment. Feel free. Oh, Ashley has posted that Seascape Alaska, who we're coordinating closely with, has stickers. So we definitely need to get those stickers going. All right, thanks, Ashley. Okay, let me share my screen again. Not seeing any questions. Great, keep going. Oh, shared the wrong screen. I'm all screwed up, guys. I'm sorry. Leave the meeting. That's what I did wrong. Patience, patience. That's the right screen. Sorry about that. Okay. All right. So FCMaP prioritization to the deep water areas. By deep water, I mean everybody has a different definition of deep water, but for the cases of for the case of FCMaP, it's the 20 to 200 meter water depth zone. I want to give special thanks to Kathleen Young with NOAA and for NOAA in general for really doing some of the heavy lifting on helping us get through the second prioritization. The first one, all the heavy lifting was done by Renee Baumstark at FWRI and his group, Ryan Druyer also, among others. There were additional, and so this couldn't have been done without Kathleen. I also want to stress this is really informal. This is very preliminary. I just got these slides yesterday late afternoon, so I barely had time to look at them and digest them. There's a lot of information, and Kathleen and I are the only ones who have seen them. So the rest of the FCMaP STAC has not even had a chance to see these. So I will try to get through this. Again, bear with me. Participants and organization types, you can see the list on the left of the different respondents that we had. It was a nice distribution. I do not believe that we had any county participation in the first one, so it's nice to see that counties have joined, and I think we did have Park Service before. We had a fair amount of academic input from COMET, from the University of Florida Center for Coastal Solutions, as well as, USGS, I kind of consider academic because they do our research focus largely. Anyway, nice distribution of state, federal, and local agencies, as well as the city of Deerfield Beach, which is awesome. So you can see the distribution of response sectors on the right-hand side, kind of dominated between local governments and research institutes were the dominant responders. Also, then state government was the smallest, and federal government, we had it close to 36%. I want to say at this point, if you're attending this call and wonder why, that you feel that you or your agency or entity should have participated or wants to contribute to this, we will open this back up for further contribution, because we definitely want to make sure we get everybody's input that wants to get input, that thinks that they should have a say in this. Okay, so here it is, statewide weighted priority. Remember, this time instead of coins, numbers of coins, we just said, tell us the high priority, medium priority, and low priority. Kathleen then took those and gave a value of 3 to every cell that was ranked high priority, 2 to every cell that was medium, and 1 to every cell that was assigned, that was colored yellow by the respondents. So then the values for in each cell were summed, and you can see here on this map that the bright reds and deep oranges, again, are the highest priority. So it looks like, again, just my initial take on it, you can see that the highest priority areas appear to be up in the Panhandle area, focused heavily right off the coast of Tampa Bay, in deeper waters. And then you can see also really kind of maybe just north of Cape Canaveral National Seashore, I would say, from the northern end of Canaveral National Seashore all the way down to the Keys, are areas of priority hotspots for the deeper water mapping. Another thing I want to point out on this map, I know it looks like in some areas that the boxes go all the way into the shoreline here and up in the Panhandle especially. It's kind of deceiving, because what happened was part of that particular grid cell was actually in deeper water, but part of it was within the 0 to 20. And those grid cells were left in. So it's a little bit deceiving, but the respondents were in fact indicating that their priorities were in the 20-meter isobath and deeper waters. Just want to make that clear. This is the highest priority per number of organizations, meaning if you look at the color coding here, the number of organizations that felt that this region was the highest priority is in red, and that was the 4, and then 3, 2, and 1, you can see. So again, we have it coming out that the majority of the respondents, the number of organizations were heavily weighted, which you would expect given the overall map, in the Panhandle off the mouth of Tampa Bay, and then largely in the Keys region. So generally, the colors represent the where ranked the highest priority, and then it represents, what we kind of said is this means that this mapping is really needed or wanted in the next 1 to 2 years. Moving to the medium, priority per number of organizations. So this is those who ranked, said it was medium. Those are heavily weighted in this case, again, in the Panhandle area, and then all along the what we call the northeast coast, as well as moving into the southeast coast, south of Canaveral, down to just north of Miami, I'd say. That's where the big concentrations are. And that represents areas where, the respondents felt that mapping would be needed, within the next 3 to 5 years. And finally, the low priority, and this is interesting, and I like the way this panned out. It really pushed the respondents to think about the offshore areas that they were interested in. And you can see some of these regions really jump out in the deep reds, where 5 organizations wanted information there, and a couple areas is kind of saddled between the Big Bend, off of the Big Bend, definitely squarely on the West Florida shelf, as well as down in this part of the southern West Florida shelf. So these are sort of, we really want data in these areas, but, if we don't have it for a half a decade to a decade, there are higher priority areas. Okay, moving to, this is not the entire Panhandle area, what we call the Panhandle area in the original prioritization region. This is just a subset that Kathleen just did a screenshot of so we could have something for today. So for this little area, this small section, it's the same color coding that you're seeing. So it's the number of organizations. And here you can see that confusion where it looks like the grid cells are going all the way inshore. And that really is not, we looked at the isobaths, and it happens to be that the isobath ran right through those grid cells. So it's a little bit deceiving. You can see that this area right in here, I think this is Mexico Beach. I'm not quite sure, just to the west of Apalachicola is a really high priority area, in that whole region around it, as well as over toward Pensacola. And on the right-hand side, you can see the justifications. And this is where, it gets interesting and needs a lot more data analysis. So the highest number of respondents that chose these areas chose it for scientific research. I think that's fascinating because I'm a scientist myself. But and then the second highest was mineral resources, which kind of makes sense because it might align with the search for sand for beach nourishment, for instance. And then cultural and historical resources coming in at 3. If we look at the MAP products, you remember we asked everyone to say, what they wanted the data for, and what MAP products or other data they would want to go with it. And it came out, and I think the scientific research piece and the desire for substrate or sub-bottom geologic characteristic in both the justification and the MAP product, and this in the MAP products, I think shows some of the academic influence. At least that's kind of my interpretation. And then the second highest, which is not surprising, backscatter, that was the most desired mapping product to accompany the bathymetry in the original prioritization. So it doesn't surprise me that it comes in fairly high here. I think it's interesting, just offshore of Tampa, the Tampa area, you can see that bright red zone just outside the 20-meter isobath, again coming in, that scientific research was the highest, and all these other justifications came in at second. And then with the MAP products that were desired, that substrate, sub-bottom geologic characterization, elevation, which has me a little confused because that's what the goal is, that we're going to have that anyway, but maybe that somebody just wants the DEM. So I guess that would make sense. And then of course a backscatter map. And then lastly, just a piece of the Keys. This isn't the entire Keys region. This is just a subsection of it for results today. You can see it's just scattered all along the Keys. And the primary or the biggest justifications, besides that good old scientific research, was commercial and recreational fishing. Not surprising whatsoever for the Keys area, and then all the other choices are coming in even. And then for MAP products, that backscatter intensity came out high, and not surprising. There's a lot of habitat to be mapped there, distinguishing between hard bottom and soft bottom, etc. And then biological, chemical, or physical samples was the second highest in this subsection of the key region. Just going through some more, and I'm just going to put out highlights. This is big and bright and colorful, and we'll be working through it. But just to kind of point out, like the top one, these were the justifications in the high priority areas statewide. Again, scientific research coming in as the primary reason, or that people wanted mapping done. Commercial and recreational fishing came in second. And then protection of or management of certain areas, like I would assume aquatic preserves, etc. And I thought public health was interesting as a good one. The whole issues with red tide and algal blooms and such. So again, this will all be analyzed and synthesized a lot better and a lot more between now and the next FCMaP meeting. Here's the mapping products in the highest priority areas. Note that the backscatter, again, not surprisingly overall, came in as the highest. And then that substrate geologic characterization was second. Samples, some type of biological, chemical, or physical samples, and elevation were tied. Basically, it's the same kind of information that was in the bar charts, just kind of viewing it a little bit differently. And so this just kind of summarize that. The justifications in map products, scientific research was the top justification for mapping, collecting bathymetry, map products, backscatter, and then you can see the different, commercial and recreational fishing, protection or management of specific areas, and public health. Those are the totals for everything. And then on the right-hand side, the map products, backscatter, sub-bottom, sampling, and just elevation data. I think I said as a DEM, I would assume. So my initial summary, and I literally was typing these an hour before this meeting, were that the shallower areas, kind of in that 20 to 40 meter isobath of the area, seem to be overall ranked the highest priority. The Panhandle, offshore Tampa Bay, and the Southeast Coast are the highest priority when you look at the statewide perspective. Areas deeper than about 40 meters, roughly, this is not totally conclusive, but for the most part, areas deeper than 40 meters were ranked as the lowest priority, but still important to map in the next 6 to 10 years. Backscatter was the highest priority mapping product overall, not surprising, similar to the original prioritization. And scientific research and substrate geology were consistently high for both the justification and the mapping products, respectively. So that, I think, is all I have. Stop sharing. And I know it was kind of a lot, and I apologize that it's as preliminary as it is, but I hope it gives you a little bit of perspective, and I'm happy to open the floor for questions or comments, or if you want to look at the slide again, or thoughts in general. Was it worth doing?
Was so engrossed in finally seeing the results for the first time, I almost forgot I was facilitating the meeting. It was interesting. Oh, I see a hand here.
Right. Yeah, Brian?
Hey, Cheryl. Just, a quick question is, doing this prioritization, the way that the FSMI was kind of put out there was in the bands, in the areas. I don't think they're necessarily going to be telling us to go out and do only specific parts of those. But is that, so, what is your intent and goal and desire with this info? Certainly we hope to be mapping more of those areas before 6 years are up.
Yeah, and that was that was arbitrary, honestly, that 6 years or so. I mean, I would say, and I think our intent or purpose is really for anyone interested in mapping, with federal agencies that want to help out mapping, NOAA and others that then contract to the private sector to map certain regions. this information, I think, is kind of critical because we know there's always going to be limited resources, right? You're never going to have enough money to do everything everywhere all the time. And so I think our goal here, and I'm happy for any of the, anybody from the FCMaP to chime in on this, but was to help drive where to start putting the resources in deeper waters when they became available or as they become available. So the years are more arbitrary than just being able to designate the locations and understand why. Does that answer your question sufficiently?
Yes, thank you.
Okay. I saw another hand up before and then it dropped. Is there anybody else? Okay, I think that probably, you guys, if you think of something, we'll have plenty of time, I think, later on, if something else comes to mind, or if you want to go back to it, we're happy to do that. So, Christy, I'm going to turn it back over to you and let you drive to the next section of the meeting.
Okay, we were scheduled to have a little break, but given there weren't as many questions, maybe we'll just go ahead and move on. Jump ahead in the agenda here a little bit to the FSMI overview. Let me share my screen here. Okay, I hope everyone can see the screen. So as I said, I'm going to do just a very quick overview. I'm familiar with this site just from running through it myself, but I really was hoping that this would help everyone know where to go to stay up to date on the FSMI project. So this is the Florida Geographic Information Office's initiatives page. And here you can find the Florida Seafloor Mapping Initiative page. And if you click on that, it will take you to the overview of the mapping initiative. And you can see there's a good bit of detail on here, but just as a quick, the state was awarded $100 million to capture bathymetric LiDAR. The mapping focus, as I understand it, currently is on 0 to 20 meters topo bathymetric LiDAR, and all the updates can be found on this hub site, this public site. At this time, DEP has contracts with 3 contractors. Fugro, Dewberry, and Tetra Tech, 2 of which you'll be hearing updates from here just in a few minutes. Tetra Tech has not started collecting data at this time, so they won't be participating in this update today. So if you click on this tab at the bottom here, you see project areas. So these are the areas that they're focusing on, and once all the vendors are collecting, DEP says that they plan to add a simple dashboard reporting the completed extents from each of these 6 regions for the 3 resources. If you click on the other tab next to it there, the collection status, so all the progress is being shared by the vendors to this public status web map. And if you scroll down and click this tab, you can zoom into an area to see the detailed 1K grid showing collection status provided as a dynamic Esri feature service from each of the data collection vendors. So this is, as I said, where you're going to want to go to really stay up to date, to see what progress has been made and what contractors are actually collecting data at the time. So if there are any questions, I can try to, as I said, it's not our website. We've just done a run through, but if anybody has any questions regarding it that I can answer, I'd be happy to. And I don't see any questions. So if that's the case, I'll turn it over. Oh, Cheryl, did you have something?
Yeah, well, I just want to add, the reason why we included that in there is because up until we started planning for this meeting, we hadn't even realized that the GIO office had created this website for anyone, a public facing website. We knew they had planned to, but I didn't realize it was as active as it is. And we just thought this broad stakeholder community. Right now, we've got 60 of you on the call. Would be interested in what Christy presented, and thanks for that overview, Christy. That was good. So yeah, we're flying through this meeting. It might be over by 1:30 or 2:30 at this rate, but that's fine. Go ahead, Christy.
Okay, I will go ahead then and turn it over to Malcolm Elliott with Fugro. I think you're muted, Malcolm.
Of course. Teams meeting without one. Thank you for that, Christy. I appreciate it. And just on that, while I find my PowerPoint here to record. No, sorry. To present Teams. That site that gets updated. So I happen to be one of the poor folks. I happen to be one of the poor folks who updates that weekly. So if you've got any questions, feel free to shoot a note to us or anybody on our team here.
Oh, good to know. Thank you, Malcolm.
Yeah. Let me know when this comes up. Just thinking about it.
Yep, I can see it.
There we go. Okay, so quick introduction on myself. Malcolm Elliott. I'm the project manager for Fugro on the hydrographic side. So any kind of multi-beam airborne LiDAR that falls under my portfolio. But specifically, I have a background in airborne LiDAR data acquisition. That's what I'm good at. That's what I know. So that's how I found myself in this role, working with Fugro. And now, of course, we have this this contract with DEP to do this collection. So, and again, I've been asked to provide a quick update. So I'll try and get through this. We are racing through, and I tend to go rather slow through slides and lose track of time. So maybe that was a good thing. So I'll try and get us back on track. Try and get us going quick. So just a quick update on, or an overview on this update. So what and where. So what regions we're working in, the Northeast and Southeast. It was mentioned before that we're one of the providers. And then the technology that we're using for actually doing the 0 to 20 meter collection, the airborne LiDAR, the completion. So what we have to do to get to completion, and some kind of outlooks timeline-wise, and what actually needs to happen to get this to DEP so that it can be shared with the general public. And then, of course, some Q&A. So I would be remiss if I didn't actually give an update on Fugro as to who we are. So Fugro, if you're not familiar, we are a global entity, primarily focused on the hydrographic customer base. So historically, we've been an oil and gas oriented industry. It comes along with a lot of safety oriented work practices. But we're seeing a large pivot in some of these spaces to renewables, and Fugro has announced its ambition to be net zero carbon emission by 2035, which is an ambitious goal given all of the assets that we employ on a day-to-day basis. And for this very specific project, the state mapping initiative includes two prime service lines that kind of work in concert and are sort of the same, but there's a slight differentiation between the two. First one being hydrographic surveys. So as I mentioned, it's the one thing that Fugro is known for and is very good at, and that's putting vessels to sea for collecting, again, multi-beam those types of those types of jobs. I've had the privilege this past year to work on two different projects that have employed USVs, like the one on the screen, in concert with some topobathy jobs. So where the topobathy and the near shore shallow water or medium to deep water areas that we consider for this project. But then more importantly, coastal resilience. So similar to what Cheryl just presented on, we're all, I'm sure most folks on this call are painfully aware of the need for more intelligent data acquisition, more intelligent data that is that can be made available to the public, that can be collected and shared, that represents kind of that in between, the halfway house between what the folks in the land like to collect and the ocean folks. So where we're at with this contract, as I mentioned, we are mapping the 0 to 20 meter boundary, and we have the northeast and southeast, so that runs from Georgia all the way to Miami, and in total that comes out to about a little over 10,000 square kilometers of seafloor to survey, which is not a small amount. That's when we're talking about Bathy LiDAR, it's a large area. It's a big effort. So in anticipation for this, we were awarded this contract back in the spring. I can't remember exactly when. I believe it was May. And then June, we mobilized 2 aircraft in Florida. 2 aircraft with 2 topobathy LiDAR systems on each one. So we mobilized before we had notice to proceed from the state, and we began engaging in our calibration, some testing, and of course some training of some new folks because we knew that we were going to be sitting around on this project for a long period of time. And we had a sense of urgency because when we were bidding this, work, and when we were planning this out, we knew that the Northeast and the Southeast in particular were going to be challenging. Not that the other areas were not going to be challenging, but we knew that these were going to be particularly challenging in that we had to focus on a specific time of the year. So when we were doing our site investigation of, and I'm going to show the Northeast and then I'll show the Southeast in a second, we were looking at weather conditions. So the Atlantic coast is a little bit different than the Gulf Coast in that the turbidity and the water quality is impacted by a few different things a little bit differently. So on the Atlantic side, large storms and sea swell are going to impact water quality more so than in the rainy season on the Gulf Coast, which again, it's the rain, it's the outflow from those 1 p.m. thunder showers that happen every day in the summer. So it's something that we had to contend with. And in doing our satellite reconnaissance, we realized that for a 3-second or a scanner that was rated with an attenuation coefficient of 3 or greater, which this contract called for, if we wanted to use any scanner that had those parameters, we would want to be focusing on June, July, and August. And we knew we had to get there. We knew we had to get more than one scanner on site for June so that we could make the most of that actual window that we had. That's the Northeast. So that's not to say that there are some areas that we can collect all year round, or that we can there are some areas that we can focus on outside of those windows, but the hardest areas to collect are going to be in those 3 months, June, July, and August. And then once September rolls around and we start to see hurricanes, like we've got Lee offshore right now, it's causing quite a bit of groundswell, which is then kind of hampering our efforts, at least right now, anyway, this week. So what does that look like when we look in the Northeast and we play that through? So where does that actually impact? And you can see it's the deeper water areas that have that really narrow band. So those between 10 and 20 meters that are going to be more impacted. Now, there's always going to be a place. Apologize, I want to play that again. There's always going to be a place along shore that it's going to be challenging year round, where there's a lot of outflow anyway, particularly off of the St. John's River, for example, in Jacksonville area. So similarly, we face a similar problem in the southeast, but particularly in the southern part of the southeast. So in the Cape Canaveral area, or sorry, not in the Cape Canaveral area, in the Miami area, we're going to have pretty good clarity all year round. There's a reason the universal test site is there. But similarly, in the offshore parts, in the northern part of the southeast, we see the same trend where May, June, July, August are going to be our best months for actually targeting this collection window. So again, similarly, the graphic which shows this, so May, June, July, August are going to be the best months to target this area. And by the time hurricane season's over and done with, it becomes more challenging. Not to say that there aren't going to be exceptions to that rule, but that's the basis. So in June, we mobilized and we calibrated and we sat around and we waited for notice to proceed for the state to actually tell us, okay, you can go ahead and you can do this work. While we were doing this, we took advantage of FIGRO's assets in the area to collect a multi-beam survey over the universal test site. So we used this to actually calibrate our scanner and do validation. We collected some targets, so some man-made targets that we knew were in the areas, and used that for actually doing some validation of the scanners and again doing some testing. So we had quite a large mobilization effort. From there, we were inevitably given notice to proceed, and we immediately same day began collection. I think it was July 5th, if I don't recall, after Independence Day. So we received notice to proceed, and we've been going ever since. This week and the week after Idalia were really the first two large periods of downtime. So to date, we've collected around 35,000 kilometers online, 1,500 line attempts, and 100 missions in the bag. And as I mentioned previously, due to clarity constraints and having missed the June collection window, we intentionally focused on the offshore areas, the areas that we knew we had 2 months or less to actually collect and get good data. That would be something that we feel confident putting our name on. So to date, the results are pretty good, as expected, given our desktop studies and reconnaissance, and again, focusing our areas on those deep water areas. And again, this is the outside of the Northeast. So again, the contour lines were as Cheryl mentioned earlier, the isobathy lines being at 20 meters, and then that also includes the 1 kilometer grid cell. So going beyond here, I think we're getting to 25-ish meters in the in-between area, which is great. So we're filling out the AOI, and these results are showing that it's very possible, given that we attempt this in the appropriate season with a deep water 3 Secchi or greater capable scanner, which is fantastic. So where we are to date in the Northeast, we finished the majority of the outside area, as I mentioned, what we deemed to be more difficult. There's still a little bit of infill to be done, but we've done our what would be considered a best effort on that tricky area. So we've spent the better part of July and all of July and all of August focusing on that area with our 2 scanners. As I mentioned earlier, pretty much up until this week, the quality has been better than expected, right up until after. So when Idalia came through, and I realized that impacted the Gulf Coast a lot more than it's impacted our area in the Northeast. We still got out of the way. We still took our scanner out of Jacksonville and our aircraft out of Jacksonville, and we remobilized it to the Fort Lauderdale area, waited for it to pass, and went back the next week. And we actually saw that week following better, or the following week, we found as good or better conditions than we had all year. So we're pretty impressed with that. I see just a quick question I'll answer before I before I forget this and we get to the end, what if I miss the data resolution and coverage? And yes, we are using RAM. So I'm going to cover this here next. And the data resolution. So what I'm showing on screen there is coursing to, I think, 8 meters, which is just for the sake of showing it. But we're looking at it's a 2 point per square meter contract or greater, and we're averaging between 2.5 and 3. So that can get you a 1 meter or 2 meter cell size. Okay, so on to answer the next question from Ashley. So yes, we are using the Fugro RAM system. So Fugro RAMs it's developed by also with a company that we contracted, Arete, to make our own in-house scanner. So there's a need for something, a small platform scanner that we could put in a small aircraft or a drone that would meet the needs of a 3 SECI scanner. So it was commissioned as a 3 SECI scanner, and that's what led to this program. So RAMS being the Rapid Airborne Multi-Beam Mapping System, it is a solid state scanner, so it doesn't have any moving parts. It doesn't have rotating mirror as you find in some of the Leica or I guess the oscillating mirror or rotating mirrors you find in the Regal systems. It's quite light, so it's around 30 pounds, the scanner itself. And then when you start adding parts and pieces to it, so as you can see, the one that we have here is on a gimbal mount. So everything you need to run that as you would a normal system. It's got quite a low power draw, and it is UAV capable. One of the nice things I mentioned is platform flexibility. We can put it in a very small aircraft compared to what we would need to put in if we had a larger system. So the main difference between RAMS and some of the other scanners is that it is a push-beam scanner. So it has a 15-degree look back and a 23.5 usable degree, plus or minus 23.5 degree scan angle on the edge of the swath, or to the edge of the swath. It goes to about 30, but we clip it back to around 23.5 just for that, just for accuracy reasons. We get a nominal pulse or point density of 2.8 points per square meter. That's the target, with a point spacing of 60 centimeters. Our ideal aircraft altitude is 325 meters above mean sea level at 110 to 120 knots. So we can push that up to 400 meters if we want to. We can go even higher, but it was suggested, 325 seems to be the sweet spot for us. And again, so this is the kind of impressive part. So for us, so most other scan companies, so again, like a Regal, Optech, they want to sell you a scanner. We don't want to sell you the scanner. We want to use the scanner. We want it to be capable for us. We commissioned it for 3KD, but it's in practice we've observed much greater than that. So up to 3.7 here in Florida, actually, off of Fort Lauderdale. So we're quite happy with it so far. So again, what makes the Fugro RAMS sensor? So the RAMS unit itself is the deep water scanner. So it's capable of doing deep water collects, and we can co-mount that with all kinds of other scanners. So here in Florida, when we say we're using a RAMS system, we're actually mounting it with a topographic scanner as well. So a Regal 680, which we're flying in concert with that system on our aircraft. So that's what gives us the full topography experience. We can also mount it with RGB NIR cameras. We typically use phase 1 platforms as well. Hyperspectral cameras. It's fit. There's the different form factors. There's 3 different form factors which we have access to, 2 of which are drone capable, and the other 2 are meant or the other 2 types are meant exclusively for putting in typical camera port in a small aircraft, such as any kind of your Cessna type of thing. We've also flown with our UAV capable systems on a Griffin Sea Hunter or the Schiebel Camcopter. We have one in Portugal right now that's on the Schiebel S100, which is exactly what's being shown on the screen there. And again, as I've mentioned, this Fugro owns and operates all of these on its own. No other company has access to these, but that's not the impressive part to me. The impressive part to me is that we have all of the development and software capabilities in-house. So if we want something changed, instead of calling up Leica and there being a 3-month lead time, I go on Teams and I ask our developers, hey, can you change this? And they say, yeah, sure. When do you need it by? How important is it? Is it project specific? And then if it's something that we need for this project, it happens like that. It happens overnight, which is fantastic. But the system itself is based off of 20 years of development of 3 generations. So this would be the 4th generation of naval mine detection sensors. So Fugro then adapted that to charting and mapping specification. So as I mentioned, it's an ever-evolving program, but really 2018 was the first year that it was in full production globally, and it's been getting more mature ever since. So just a background on how the push broom sensor works. It snaps an image that the operator sees online. So the image that you're seeing there is what the operator is seeing as they're online. So they see that. If they see water surface and they see bottom detection, they know that they're actually being productive. They're seeing that light up, and they're seeing bathy. So if we happen to be in an area that's more turbid, or we're unable to see bottoms, it would be quite apparent to the operator that they're not actually getting that detection. And again, this is one of the benefits to using an aircraft-based system versus a UAV or drone, is that in the aircraft you have that experienced operator online. So if they notice that things are not productive or not as productive as they could be, they can abort the mission and go home. On the processing side, each of these beams, each of these images is derived from one beam, and then that's split up into 1,000, and again 900 usable because we split off some amount of the edge. You have 1,000 beams. Each of those beams has a unique waveform, and that's how we actually derive the point, get the actual pick in the final product. So onto the processing side. So the FCMaP RPM, branch processing module, it is Fugro licensed. It is maintained by our development team, and so again, I can pick up a phone or go on Teams and ask for any changes. But this cross section of the flight line is where the points actually come from. So the water surface, any topo that may be there, and bathy are easily identifiable, and this is how refraction is actually done. So online, assuming that all the classification is correct out of the scanner. If it's not, we get to go back and make adjustments, and that's done 99.9% of the time. It's accurate. When we're doing our last QC, we notice, okay, well, this classification is incorrect, so therefore we know that the refraction is going to be incorrect. So we have to go back to RPM and reprocess that out. The nice thing about that is because we have such a high degree of confidence in our ability, at least in clear water, to what the preliminary classification is like, we can make real-time judgments without having analysts go through and doing a whole bunch of point killing and finding noise in the data. Basically, that's something that I don't necessarily we've gotten past, but it's been significantly reduced. I have background using the Regal and the Chiropteris and the Leica systems, and this is a much different beast. It's much easier to process through and to visually see on a line by line and image by image basis, and then going back in and looking at the waveforms and validating. Okay, are these picks real? Are these actually bottom? So it's an easier system to use in my experience. And going back to the RPM, so this is from when we were doing our calibration data sets or calibration sets in June. We were looking at some targets, and I believe, so there's no actual metrics or graticules to show you how deep this is here. I believe this is a 1 meter target in around 15 meters of water, if I recall correctly. So this is what it looks like in the actual image, the waveform. There's one thing, I've made a blunder when I grabbed the screenshot, and you'll notice that in the flattened image on the bottom here, you'll notice that the water surface isn't exactly flat, and that's because my roll, pitch, and yaw values are all zeros. So I only noticed that when I was going through my presentation. So I have to go back and find this again and put in the proper bore site before I actually do this next time. But you can see that the object is there. And then, of course, as I mentioned earlier, because we get a preliminary look without having to do without any analyst having to go through run macros, we don't have to do any manual editing to actually get to a stage where we can look at what we've flown and we can make an assessment on. So far this was as of sometime last year, might have been before Adalia, but we can actually go through and make an assessment of where we're actually seeing bathy, and we don't have to consider noise. It gives us a very quick analysis of the or a quick look of the data. So again, this is just showing the northeast and southeast what we've collected so far, and it's just a reflection again of the GIS layer that shows the offshore areas that we focused on first, and we knew that was going to close out. And we've only just started working in the southeast. So we moved a scanner down there a couple weeks ago. And we've been running this grid pattern just to find where, if anywhere, we're going to have difficulty. And in those areas, we want to focus first. So if we're not seeing any penetration in a particular area, we want to try and focus on that first. So that's why that grid pattern exists. Our operators like to call it tic-tac-toe because they're drawing tic-tac-toe lines. And then, of course, I don't want to give you the idea that it's easy. We do have a full processing suite to go through. So there is still a lot to do. It's not just push a button and the data's done. We still have some calibration to do. There will still be some classification, particularly with the topo data set, and then of course the development. And I can't show you everything that's in our workflow here, but that's generally what it looks like. And then, of course, we don't have a final data set to hand out because we're still in the collection mode. But this is the slide where I put the final product. So I have to put something there from a previous job. So hopefully, the next time we give an update, we'll be able to show you something a little more final. And looking forward, we're doing our ground control campaign this September. We're actually starting on Monday. The field crew is going out. We're hoping to wrap up the data collection in the Northeast and wrap up the data collection in the Southeast. Probably won't be until sometime in October or November before we can put a projection on how much longer it's going to be, particularly because, as I mentioned earlier, as hurricane season is now coming in, it becomes problematic for us to say, okay, it's going to take us 2 weeks to finish collection because we don't know. Once we get into more stormy weather. So it's too early to put a final date on it, but we are progressing quite well, at least up until this week. So that's all I have. I told you I'd catch us back up. I didn't quite do that. I can answer some of the questions in chat unless we want to do some hand raising first.
And that's fine. I see we have one request for you to describe your determination for water clarity, objective or subjective, and to what depth.
Yeah, well, so to what depth? First of all, we're looking for penetration. So that image I showed you that the operator sees on a day-to-day basis. So we want to see that light up on every line, right? But we also have to make a determination. Some of our lines go well beyond the 20-meter boundary, and if we're dropping out at beyond 25 meters, then that's something that we have to take into consideration. And bathylighter is unfortunately a little bit subjective. At that point, you do have to draw a line at some point. And there are mechanisms in this contract where we say, okay, well, if we didn't get good data on this mission, what are the conditions for which we will have to go back? One of those is how many times have we attempted it? How many times have we done a reconnaissance in the area? How many times and also what is the water clarity based off of? So we use satellite reconnaissance on daily. There's a bit of a delay, 2-day delay before we have access to some of the satellite data, but that gives us a determination of, okay, we flew here on this day. We knew we should have been able to get to 20 meters, but we didn't. Why was that? And so was that sometimes, is there a plume or a shelf of suspended sediments in the water column? We see that quite a bit, at which point we have to try and go back on a future day and hope that that sediment has moved on. It's gone further up the coast. And that becomes another one of our attempts in that on that particular area. So that's some of that determination has to happen in the office. So the data gets brought back to the field office, it gets compiled, and then it gets sent up to the portal. We use something called Fugro back to base, and then that gets our last data, and we can look at it and we can do our QA/QC, and then of course the PLS then gets to sign off on it and say yes, this mission was a success, or no, this mission was not a success. You can go back here, and here, and do better. So it's an ongoing process, and it doesn't matter where you are in the world. If you're in Florida, if you're in like I mentioned, we're in Portugal right now on another project, and in France, we're in Australia or in the Middle East. With this system, it's always a learning opportunity based on the local environment, and that's one of the interesting things about bathylighter. So sometimes subjective, yes, but we're striving for that 20 meter contour.
Great, thank you, Malcolm. Are there any other questions? You want to raise your hand or put it in chat? Either way works.
This is Larry Hanley.
Larry.
Hi. I asked the last question, which is sort of you answered. But okay, my other one is, you're doing the work right now in an area that basically has very little to none vegetative, a vegetative or a benthic environment at the bottom. If you're doing an area, and I know you're staying southeast and north and northeast, but the possibility is that some of the inland areas that you're in, on St. John's, in the St. John's area, in that there'll be vegetation. How are you separating out? So it's multi-beam, I know. So you didn't explain really what it looked to me like you're going solely for and determining that everything is basically a bottom profile.
Yeah. So in the preliminary grids that I show, yeah, we're just finding the bottom. So that's going to be the first return of something. So we do get the full water column analysis, and we can reclassify points if there's extra features there, right? But we're sticking to and I can't remember off the top of my head what the ASPRS codes are that we're supposed to be using for this are.
Right.
But that's something that we can go down that road if it's needed. So if this were a contract for mapping eelgrass or any kind of any kind of vegetation, any kind of submerged vegetation, that would become a production activity after the data has been processed to last, right? That would become an activity where then the analyst would have to go in, and somebody trained, of course, in the matter, who would know what they're looking for, would have to go in and actually find and identify those features. So it's definitely something that would be apparent in the data.
Okay.
Yeah.
Thanks, Malcolm.
Yeah, no problem.
Are there any more questions?
So I
Go
just
ahead,
want
Cheryl.
to, I'm going to chime in really quick. I'm getting some messages. It appears that some folks at different agencies, so not just everybody sitting in one room, were having problems with seeing Malcolm's slides advance. And I didn't see them. It looked fine to me. So I just want to apologize for that. I don't know what the resolution would be because I didn't see it. But I just wanted to say that, remember, this is being recorded. So if you wanted to go back, you could always just fast forward to Malcolm's presentation or even parts of Malcolm's presentation to have a look at it. We'll, of course, let everybody know when it's posted, when the recording is posted to the FCMaP hub. So apologies, and hopefully the next presentation doesn't have the same problems.
Thanks. Apologies for that.
I could see it just fine as well, so I'm not sure what happened, but as Cheryl said, we'll have a recording of it, so that'll be good. If there are no more questions, though, Malcolm, thank you. That was very thorough. We appreciate all the information, and we look forward to hearing the final updates when you guys are completed your collection.
So do we.
Great.
Thank you.
Thank you. So with that, we'll move on to Amar Nayagandhi with Dewberry.
Yes, hi everyone. Good afternoon. Look forward to this presentation. I will bring up my slide deck. The way we structured this is we have it in sort of two parts. We are going to be presenting a slide deck. I'll present that, and then Emily Clip will go into a dashboard that we have that will go deeper into the data. And I have to make this the pun on the word deep. I won't go as deep as Michael did in the technology, but we will go deep into the data, and you'll see some pretty cool features there as well that we've collected so far. So thanks again for giving us the opportunity to provide you an update. Again, just as an introduction, I'm Amar Nayagandhi. I'm a Senior Vice President with Dewberry, and I lead our Geospatial and Technology Solutions Group. And along with me, Emily Clip is going to present. She is the project manager for this particular project. She's also a topography LiDAR specialist, and will be showing you a lot of the data as well that we've collected so far. So just a brief overview of what we were awarded as part of this effort. We of the FSMI project, so we were awarded regions 5 and 6, which is basically the Big Bend area and the Panhandle area. The Big Bend is a much bigger region. It's about 14,000 square kilometers. The Panhandle is much smaller. I think it's about 4,800 square kilometers. So the two regions, but big difference in the sizes of those two regions. You'll notice that the Big Bend actually does not go all the way to the coast, because we have acquired data for NOAA in the past along a lot of this area as well. So because there was existing data, there wasn't a need to acquire that again. And I'll actually show you a couple of examples of that moving forward. And I think this image here shows some of that as well, but I'll get into that in a little bit. Actually, this one does. This particular image shows some of the work we have done. for other agencies prior to the FSMI project, and many of these data were incorporated. So the areas, the Big Bend that I mentioned, these two blue areas have already been acquired, and we are in the process of delivering the data to NOAA. We've also acquired some data in the Tampa Bay area as well, that is not part of our region, but we have acquired this in the past, and some other projects that we've done in the past as well. The systems that we are primarily using is the seasonal supernova. It's a teledyne optics system. It's called the Coastal Zone Mapping and Imaging LiDAR. It is a fairly powerful topobathy and mostly a bathymetric LiDAR system. It has some significant topographic capabilities as well. Some of the key factors of this system is that it uses a very, very high power laser pulse, and it splits that beam, or the receiving channels are sort of split into 7 shallow channels and 1 deep channel. So one laser source enables the ability for us to get relatively shallow bathymetry, as well as the deeper channel allows us to get deeper into getting deeper into deeper waters as well. And we are seeing some great effects of that, especially as we were looking at some data in Big Bend, in the really 20 to even beyond 20 meters deep. We're seeing how that deep channel was giving us some really good bathymetry data as well. Given the way the system works, the density of the data density of the system with the 7 shallow channels and the 1 deep channel allows us to get 6 to 8 points per square meter. Now, obviously, as you go deeper, and if you start relying more and more on the deep channel, then you're not getting that same point density. However, you still have a fair number of returns in the shallow channel. But again, as you get deeper, the footprint of the beam also gets a lot wider. So having to get really high density data in the deeper areas is not as needed, because you are looking at a footprint of the laser pulse that is spreading quite a bit as you get into the deeper waters as well. This particular sensor, and as stated by the system manufacturer, and based on comparing it with some of the other sensors available, is known to be the deepest as well. So it can do up to 3.5 times or more Secchi depths. It does have it more than the Secchi depth. It does look at its performance, or the system specifications mention its performance in terms of KDD max, which is 4.4. Again, really high number, and definitely meets the requirements of the specifications for this FSMI contract. We do have a camera that's with it as well, so we are collecting imagery mostly for quick looks and making sure when we are editing the data that as we are collecting the imagery, it makes sense for us to in terms of what we are seeing in the water column and how turbid it is and things like that. So that's really useful as well. And one other part of this is we are using and Teledyne Optic has moved its software platform, the one that processes the raw data, into a sort of an XYZ point cloud. It's moved it to Keras, and so we are able to use a lot of the features in Keras, and many in the multi-beam world are familiar with Keras. So it allows us to do that, and we are working closely with Teledyne Optic almost on a daily basis, working with them to work on new techniques and work together as we try to improve the algorithms, whether using AI/ML techniques or just especially for deriving the water surface, or to any bugs in the software. We are working closely with them so that those can be fixed as well. We also have the Regal VQ880G2 topobathy LiDAR sensor. I won't go too much into details about this because at this time, at least, we are not using this particular sensor for this project. It's meant for shallow waters, and given that most of our region, there may be some areas in the Panhandle where we have some really shallow waters, but because of Big Bend and what we had already collected before, we may not need this sensor for this particular project for the 2 regions that have been assigned to us. But we do have this. I should mention that we have the seasonal supernova. We actually have, up until now, we've had one seasonal supernova, and starting next month, we're going to have two. So we are going to have the potential for putting two of these sensors, depending on our need in terms of meeting some of the requirements, both in terms of when the weather patterns are good for us to collect data, as well as to make sure that we work towards meeting the requirements of the contract deliverables as well. So I'll give you some focus on the status, and I think Malcolm did a really good job of trying to explain, what's happening out in the Atlantic versus the Gulf in the summer months. I can tell you, when we were awarded this, when we got the final notice to proceed in the summer timeframe, it was around June. I was really nervous to get our systems out there and starting to collect data, because that's the time in Florida, as many of you who live on the Gulf Coast know, that you start getting these afternoon thunderstorms, and it churns up the water, and you start seeing, with the kind of rainfall we see, you start seeing, sediment sort of from onshore coming offshore, and it creates an environment where it gets harder and harder to get good water clarity. I was very pleased, and I think our team was very happy to see that we were actually able to collect some pretty good data. And I think one of the key focus, especially in the Big Bend region, and one of the key reasons was we were much further offshore. So as long as we were sort of making sure we were not in the midst of all of these thunderstorms and, flying really early in the mornings, literally starting flights at 4 a.m. and things like that, it did help us get some really good data as well, and has allowed us to collect data. We were continuously collecting data, had our sensor out there till Idalia happened, and after Idalia, we have for this month, we have decided to hold off on collections because it really churned up the water, as well as the rate of these storm events, as well as these afternoon thunder showers, has just increased. So we are seeing weather patterns in the Gulf right now, especially in the month of September, that suggests that we are not going to be able to fly as much. I think September 8th, and Emily can correct me if I'm wrong, but was one of our last flights we did in the Panhandle region. What says accepted, active, flown, and rejected are really internal things. So when we fly it and we are happy with the data as we review it, we call it accepted. Active means what needs to be flown. Flown means what's flown but not been reviewed as yet, and then rejected is what we know we need to refly as well. So that's really what those terms mean. We also have this. The tile processing status that we provide to FDEP, and this is more in line with what is required as part of our delivery mechanism in terms of providing status. And once again, the nomenclature is when it's under contract means we haven't yet flown. Collection underway is obviously what it is. First quality assurance pending, which is a large part of it, means we've reviewed everything, and we know that, or we are in the midst of reviewing, and then the additional collection underway, which is marked in red, are a few lines which we know that we need to refly for various reasons as well. So this is overall status of where we are with this. I think I have a table here that again shows this is in terms of number of tiles. The key thing to look at is this number 3, which is first quality assurance pending, which means that for region 5, we've completed about 31% of the area, with maybe 1% that we feel we need to refly. So that's about 30% complete. And then for region 6 is 20%. Now, keep in mind, region 6 is actually a smaller area, and we could finish that a lot quicker. But we really believe that the water clarity in those areas are not as good as they were in Big Bend. So we decided to focus on Big Bend. And we really feel that when we get into the winter months, November onwards really is when we'll start seeing better quality data, better quality conditions, I should say, in those areas. And so that's our plan and strategy sort of moving forward in terms of what we are going to do. And we will have, up to two of these seasonal sensors available as well as needed. There was a question, I think, on the chat earlier as well related to how do we define and how do we look at water quality and things like that, make decisions as to whether we fly or not. And I think, again, one thing Malcolm pointed out was all the operators are well trained with us as well to make sure that when they are looking at the data as it's being collected, they get to see a display that suggests, whether you're getting bottom returns or not. If it's daytime, sometimes they can even look out of the window and see if there is good data, if there's good conditions to collect. But we go much beyond that. We actually we look at so many different metrics, including direction of wind, which actually sometimes is one of the most impactful in terms of whether we get good quality water conditions or not, because if it changes in direction of winds, you could see sediments being, in the water column moving all over the place, and that can make a big difference as well. We are working with T-Carta, and this is general over a lot of different projects that we are doing, where we are looking at satellite-derived water quality metrics as well. This is still pretty early on, but we are seeing some really good what we are doing is we are looking at some of these focus areas. So we've selected these multiple sites, and we are reviewing the data, reviewing the metrics from these multiple sites on a daily basis. So we are reviewing these data on a daily basis. We're also looking at weather patterns, etc., to determine when to fly, and making our decisions based on that. I mentioned the tracking portal, and Emily's actually going to go into a little bit of depth, showing you those what we've collected so far. But I just wanted to give you a sense of what this looks like. And this is actually data we had collected for NOAA for the Big Bend project. So this is the area that we are not collecting right now because we had collected it previously as well. And again, this is just showing you an overview. We have a lot of different layers that we can put into it. It's custom. It's built by us under our own dimensional view platform that we have. And that allows us to look at tide gauges, nautical charts, weather radars. We also have the ability to look at the aircraft as it's flying, live in terms of where it's located. And the biggest advantage to this really is looking at areas when we are the quick look maps that we produce. So we produce quick look maps within a day or two of the acquisition, and we put it on this platform. And that allows us to look at it to show our clients and stakeholders what the data look like as well. And then for us, it also helps us define areas where we need to refly as well. So this is a great example where when we flew, and these were different days, and just a great example, you could fly 2 or 3 days later, and you might see turbidity plumes that cause us to not be able to get good bathymetry data as well. So this was a great example of a couple of missions we flew, and then we knew those would need reflight. So we would go back and refly them, again, put the quick look maps, and then that's what you would see as well. So this is something that Emily is going to show, and I think she's going to show this right after this slide, because I should mention that we all know Idalia passed through, and it actually went right over the Big Bend area. I mean, literally, it flew. The path was right over it. So we were quite nervous from a couple of fronts. One is because we've not finished the acquisition, right? So when we go back and collect data, what kind of temporal offsets are we going to see in the data that could have an impact in what the final product looks like? The more we've been looking at this, one of the things we are noticing is that because we were so far offshore, we don't expect it to have a huge impact. We won't know until we start recollecting again in terms of what temporal impacts it's going to be. But we do feel that as we've been much further offshore, the impact in sort of that change, the temporal change in the bathymetry is going to be, less impactful, I think, than what it would have been if we were much closer to the shore. So we are going to keep a close eye on the data as well. And again, our quick look maps are definitely going to show, quickly going to show if we are seeing any temporal differences or not. I'll now pass it on to Emily, she's going to show you the portal. Over to you, Emily.
All right, thanks, Mar. Go ahead and share my screen here. Can everyone see that okay? Live demo, so.
Yes, we can see it.
Fingers crossed. Okay, great. All right. So yeah, as Amara was speaking, we create acquisition tracking portals for the majority of our LiDAR projects here in-house, not only for our own benefit, but our clients. They are essentially Esri-based. So as Amar mentioned, there's, a multitude of layers and that you can add, pretty much anything that you can add in ARC, ARC Pro, ARC Map, we can, add into these portals as defined as needed by the client or by us when reviewing these data. So just kind of, I'll go through a quick tour of this portal. So, we do have the two regions. We are keeping them separate in these portals. So we have one region for Panhandle, one region for Big Bend. Here is our boundary. And let me turn on our tile status. So this is actually the same tile status that feeds into the FGIO website that we were showing earlier. So again, as Malcolm said, I am the updater of these tiles. So if you do have any questions, feel free to reach out. And so beyond the tiles, we also have kind of what, Amar was showing in his slide, a screenshot, our active flight lines. So you can see we've got one area that we were kind of concentrating on here in the Panhandle region. The gray lines have been flown and accepted. And then we went back just a few days ago to refly and fill in just a couple areas we wanted to try and get real quick before we kind of halted acquisition because of the weather conditions. So a really great thing that we can see, as Amar was mentioning, let me turn on our quick look mosaic here. And essentially these quick looks are not calibrated. It's just roughly processed, the initial processing of the data that we can output to get this general overview of what's going on. What have we collected? So we can see essentially the lowest return, right? So whether that be bottom or some kind of noise in the water column or water surface, it really helps us, get a general idea of what's going on. So beyond that, we can, we do our waveform interrogation and, there's other items that we review as well, but this really gives us that good picture of, of what's going on in full. And so as you can see here in the Panhandle area, again, the boundary is the 20-meter isobath, right? So we're not quite getting to that in this area. So this was collected the end of July. It's better than I expected for July, but we do realize and we will continue to monitor the area as Amar discussed in later months in November when we expect the clarity conditions to get better. So what we're seeing here is really fantastic bottom in the near shore areas, and then as we can see, we get deeper. It jumps up, right? So this is colored by elevation. So when it jumps up here and that is indicative of not bottom coverage, whether it be some sort of sediment layer in the water column or water surface returns. So that lets us know that we're not getting much, if any, bottom returns in these areas. I'm just gonna give everyone a quick view here of, really just these quickly processed data really give us a great amount of detail. Obviously, we will go back and reprocess, data to get better and complete returns by, waveform processing and using multiple different algorithms to tease out more data. And then obviously the calibration and the post-processing and the manual cleanup for the final classification and everything still needs to be done. But again, as you can see here, right off the bat, these gives us a really great idea of what we're seeing. I figured everyone would want to get a quick view of what we have so far. So I wanted to go over that. And then next I will jump to the Big Bend area. So here we've spent quite a bit more time, right? So I guess I should say Panhandle, that was a total of 2 missions that took to acquire the Panhandle area. So really small, really quick. But we've been working in the Big Bend quite a bit longer. We started the beginning of July and have been acquiring as we've been able to until just before Idalia came to visit. So with that, I will turn on our, let's see, our tile status. So again, this is the same status that feeds into that FGIO site. Let me turn on our legend here. So you can see our tiles under contract. First quality assurance pending and these pink reddish tiles here. And then we've identified some areas that will likely refly in the purple. And then our next area that we'll continue working on here is this blue area. And so you can see that is reflected in our flight line update as well. And I'll just go on to mention that, you know, again, these different layers that we can add, right? So we can add our nautical charting. We have live radar, which I'm actually going to turn off so it doesn't preclude viewing of the coverage raster. You know, so, you know, like I said, anything that you can use in ARC, we can add in here to help our clients and ourselves view the data as a whole. So this is our coverage so far of the Big Bend area. I will focus in first to this area here where it jumps up and is orange. And, you know, you can see this is the outflow of, you know, we've got the outflow of the Withlacoochee River, Crystal River, Wakasasa River. So, you know, all of these different really tannic rivers are outflowing here. And so kind of as expected, especially in the summertime, especially with all the rains, you know, we are getting these turbidity plumes in this area. So again, that's something we'll continue to monitor later in the winter months and you know, try and attempt to go back and get better collects here. A good example of, you know, kind of something that could clue us into you know, there are better days, right? There are better conditions. Is we did a cross flight on a different day, and you can see on the main mission day, this orange is all, you know, turbidity and not bottom returns, but on a different time, we did this cross flight and we were able to get, you know, some bottom returns in there. So that, you know, helps us understand that, you know, this is a very fluid, dynamic, you know, sediment moving in here in different conditions. So, but beyond that, we really are, you know, again, this is just quickly processed. So we will see artifacts here, which, you know, we'll go in and do some waveform reprocessing. And this is just an artifact of the water surface is being defined in the waveform, kind of not quite where it's supposed to be. So we'll go back and kind of go through that and you know, pick the better water surface out of the waveform and reprocess those data to get those bottoms. And again, this is the 20-meter isobath, and you can see all of our lines that are extending beyond that. This is full bathy bottom coverage. So, and this is a 5-meter cell size resolution dim. So we're getting some really, really cool features across the area and throughout this whole Big Bend area. And that is kind of, we've considered ourselves lucky over the summer months to get this data. And so that is kind of why we've focused more on the offshore areas, because we've been finding that even throughout the summer, you know, more offshore in those deeper waters, we were getting better quality conditions. So, Mar, anything else you want me to show?
No, we'd love to, if there are any questions or anything else. A couple of things I wanted to say. We did, first of all, I looked up my notes again. I got the numbers wrong for the size of the area. So Big Bend is 11,500 square kilometers and the Panhandle is 1,800 square kilometers. I think I'd said 4,000, so I was wrong there. We would wish to do 4,000, but we were, so that's, I just wanted to correct myself there. And the other thing is, I agree with Emily. We've been very lucky so far, especially in this offshore area this time of the year. But we started seeing our luck run run out as we were getting into the month of September. And obviously for that, what you don't see in this map are the numerous days when we would actually go out because we felt we were close enough, where we were staged or based out of, to go and see, because sometimes you look at all these conditions and you think it's a good time to fly, or maybe you think you might get luckier if you are there and you can get some good water clarity. But we've come back without collecting anything, or you go there and it starts raining and then you come back. So there have been few of those days as well in between. And so for now we have decided to come back. So sort of last week we decided to stop halt acquisition, and come back probably in early October, and resume again.
Yeah, and just to add kind of to what you said, Amar, and as Malcolm mentioned as well, we do have the experienced sensor operators on board, and they are able to see those waveforms as they're flying and as those waveforms are being collected. So, they can tell, for instance, if they've got to an area like this, they can tell that they're not getting good returns. And so then that would guide their judgment of whether they should just call the day and come home or not. So.
Are there any questions? Thank you so much, Amar and Emily. That was excellent. We appreciate all of the information you provided.
I have a question.
Okay.
And this is, well, either of you could answer this, but so Amar, you in your presentation, you noted that you're collecting more further offshore in the Big Bend area because NOAA had previously contracted you to fly the areas closer to the shoreline. How old are those data?
I'm going to let Emily answer that. She was managing that project as well.
Okay. Yeah, so the NOAA Big Bend data were collected last year. So
Okay.
Yeah. And then there is also a stretch of data right along the shoreline that was collected for NOAA for a post-Hurricane Michael response. And I think that was in 2020-ish.
Okay.
Yeah. Or 2019, I'm sorry.
It was 2019.
Yeah.
Okay. Is there, second question, is there, based on that, is there in your contract like a cutoff? How old can the data be to be considered where it doesn't have to be repeated, I guess is what I'm asking.
So the way I'll answer that question is we were assigned a region, so we didn't come back and say, oh, we've already collected this before, so we are not collecting it now. FDEP gave us the region, keeping in mind that that the other data had already been acquired. Okay. So we are not, we didn't have to it's just that they gave us an area and that's what we are collecting.
Okay. And you made the judgment call that last year was recent enough, which I would agree with, obviously.
Yeah, but we weren't, the area we got did not include the collection done by NOAA.
Yeah. Other questions?
Okay. There's one more question, I believe. Brian.
Hi, yes, thank you. This is a great presentation. I really appreciate the updates, everyone. I think it's fantastic that this effort is happening. Given the prioritization for the deep stuff that we just saw and understanding the efforts that are now being done, are the limitations or the limits on the surveying right now based solely on that 20-meter bathy zone, or are there some instances where we could take advantage of having, since it could just be a couple more flight lines to get to a deeper depth, or perhaps even a LiDAR extinction in some cases. How is the boundary of that 20-meter isobat being handled?
From a contractual point and from as a vendor, the only thing I'll say is that we have been given a region to fly, and that's what we are focusing on. if we collect extra data, and we do because we have overlaps and we can go beyond. In a way, I would love to go as far as we can if we see good water clarity days, to go as far out as we can. But we do have a contractual obligation to survey the area that we've been given. But I would say that I think this is a discussion for FDEP to consider as well, because it appears that these systems may be capable of going beyond 20 meters, and there could be a potential of collects with LiDAR, depending on water clarity as well in some of these areas beyond that 20-meter boundary.
Thank you. Yeah, because it seems like a lot of the prioritization was still in that 20 to 40 meter depth zone, which a lot of
Yeah.
LiDAR systems would. And if you're already out there, geez, that could be half the battle, at least on the East Coast. I understand the West Coast is much more about that, but something to consider, Cheryl, moving forward with this group, if you can push, some sort of recommendations up the ladder.
Yeah, we try. I'll just leave it at that. I agree. There's restrictions to the contracting, and it is the way it is. We'll certainly pass the word along. I agree with you. It does look like in a lot of these areas, especially on the East Coast, and I think from what you guys are showing, probably Big Bend too, at the right time of year. That you might even be able to get out to, let's say, consistently the 30-meter isobath, but that's a good suggestion. With that.
Thank you, Brian. Are there any more questions? If not, I would like to say thank you very much to Malcolm, Amar, and Emily. And
There's another question.
Oh, I didn't see it. Sorry about that. Larry, go ahead.
Yeah, I want to ask Emily, in the I know you said that the analysis that you showed us in those quick maps was just a quick processing that you had done, and then you pointed out some areas that had some neat looking features, and that down there in the southeast, the possibility of some of that being soft bottom that is presenting that. I assume in your processing, you'll go back and you'll be teasing out those kind of areas from what is actually the bottom surface.
Yes.
Is there then going to be a map that will come out then of those features that were teased out that were above the bottom plane, and we'll get a separate map of that as far as what are potential benthic habitats in that area?
So contractually, our deliverables are for the digital elevation model of the bathymetric bottom and ground, so classes 2 and 40. But also a classified point cloud, right? So from that point cloud, you'll have, we get returns throughout the water column, throughout, different, points, whether it hits vegetation, hard bottom, soft bottom, corals, and then above ground as well, right? So you'll have all of that point information within that LAS point cloud that will be tiled. So it's, little easier to work with, but unfortunately, there's not a deliverable for anything other than the point cloud and the DEM.
Okay. So Cheryl, there's another thing for you to work on too, to see if we can get that point cloud to be able to classify.
We'll put it on the list. We can certainly make suggestions, but whether or not they'll be incorporated is up to DEP. But good ideas both, Brian and Larry.
Thank you, Larry. Is there anyone else that has a question? If not, I'll turn it over to Cheryl to wrap things up and give us a little closing.
Thank you, Amar and Emily and Malcolm as well. These were all good presentations. Larry, your hand's still up, by the way. So just a couple things. I hope that this was worthwhile. At some point, we had as many as 65 people on the call. 86 had registered, so it's a pretty good percentage turnout. People are dropping off now, but I understand we're wrapping up. So one of the reasons why we wanted to have this mid-year forum and why the prioritization outcomes were kind of so rushed is because we've made the decision that, traditionally we seem to have been having the yearly in-person FCMaP summits in early December, which is a really bad time. It falls between the holidays. There's all kinds of other stuff going on. So we decided we're going to push the more formal facilitated summit out in person out until probably late February, maybe March, something like that timeframe. But we wanted to make sure we engaged with you, our stakeholder community of practice, right? And so we knew the FSMI the data collection had started, so we're really excited we could get the vendors to come on board and give presentations. Obviously, at the summit, you'll get a lot more, and hopefully from Tetra Tech as well, and starting to see some of the products and whatnot. So I just wanted to kind of give you that time frame of when to look for the summit. We haven't started any kind of formal planning. It'll of course likely be in St. Pete. And I just think that we'll continue to work on the data analytics for the prioritization, and once we have something more finalized, we'll be posting it to the hub. Is probably also writing up some kind of white paper or something on that. So Christy, I didn't know if there was anything else you wanted to share. Do you want to talk a little bit about the FIO hub that's in progress, or?
I can. We will be taking over. FWC has in the past done a tremendous amount of work putting together the FCMaP hub and providing all the prioritization from 2019, the data, all of that information, the FCMaP history, the accomplishments, story map. However, FIO, now that we have me, the coordinator for FCMaP, I have been working on getting that kind of under FIO's purview so that we can kind of take that load off of FWC, FWRI, so that they aren't burdened with it as much. So I've been working on that, and we're really close to putting it out there for the public, just getting some last minute reviews and edits from the stack and FIO staff. So look for that in the soon, I guess, coming up. And I was going to, I guess the other thing was just share the screen, because I wanted to make sure that we said thank you. Oh, it's not sharing for me now. Let me see. There we go. I think everybody can see that, but we really wanted to say a big thank you to NOAA, especially Kathleen Young. As Cheryl said, she's been working on getting all of the data to Cheryl and the graphics, FWC as well. And we really wanted to just say thank you to everyone for, again, taking the time to be here, because we know that you're all very busy. Subscribe to the FCMaP newsletter up there with the QR code. And again, feel free to contact me. My email address is below if you have any comments, questions, information, anything that you need. So we appreciate you all. Thank you very much.
Al, did you have something that you wanted to contribute? You turned your camera on. No? Okay. It's not. Good to see you, Al.
Just got here, Cheryl.
Well, I'm glad you could make it.
Just in time for the end.
Yeah. Okay. Thank you.
Well, we have a
Christy,
recording for you.
Yeah. Yeah. Remember, everyone, it was recorded. Christy, thanks for your pulling this all together, and to Kathleen. And once again, thanks everybody, and you'll be hearing from us.
Thank you. Bye, everybody.